Good morning, dear students. Welcome to Kundrachandra Higher Secondary School. So, let us continue our also in a straight line. So, in this video lecture, we are discussing about the graphical representation or the graphical relation between the displacement and time and the velocity and time. Clear all of you? Okay. So, in this class, first of all, we will discuss about how the displacement versus time can be represented or can be visualized using a graph. Similarly, how the velocity and time represented graphically or visually here. Okay. So, come to the first displacement versus time. So, now one by one we have discussed. So, come to the first, the A graph number A. So, all of you look at the figure. So, the graph is having two axes. This is your x-axis, this is your y-axis. In the x-axis, we taken it as t, and the y-axis is taken as displacement. Okay? So this is your time, this is your displacement. The x-axis is your time, the y-axis is your displacement. Now, if you look at the figure, so in this figure, the graph is a parallel line. The graph is a parallel line to the time axis. That means, what does it mean? What the graph signifies? The graph signifies that the object or the body is at rest. It will not having any motion. That's why at the position x0, as the look at it, as the time increases, the position of the object remains as it is, remains fixed. So that's why this figure number A, the displacement versus time graph, signifies that the body is at rest. Clear all of you? Okay. Now this is the first figure. So that means it is clear that when the graph is parallel to time axis, the graph signifies the body is at rest. Okay, thank you. Then come to our figure number B. All of you look at it. Look at the figure. So in this figure number B is a very interesting thing. So look at it. The graph is not starting from the origin. Okay, the graph is starting from a displacement x0. That means it is not starting at a displacement or at origin. It is starting at a displacement 0. So don't worry about that one. But our main important point is that look at it. The graph is a straight line. The graph is a straight line. Okay, straight line means the x is proportional to t. So as the x increases, the same equiproportion that t increases. As the x or displacement increases, in that equiproportion the time also increases. Okay, so that's why that type of motion is having a uniform velocity. Clear? That type of motion is a uniform velocity. Okay, so it will having a uniform velocity motion. So look at here. Suppose I will have a two displacement or two position I will take. One is x1, one is x2. At time t1, the position of the object is x1. At time t2, the position of the object is x2. Okay. So now, suppose I will extend it and I will join it in this graph. Then what I will get? Look at it. So I will get the slope. This one is your slope. So all of you look at this figure. Okay. So this one is the slope. That means this is the angle theta. Okay. So if I will move to the trigonometry, then this will be a right angle triangle. All of you know this is a right angle triangle. Okay. So right angle triangle, this is the perpendicular and this is the base. So this is the angle theta. So now the slope is nothing but your tan theta. So tan theta is nothing but the slope. This is not is your p divided by b. The formula is perpendicular divided by base according to the trigonometry. So tan theta is equal to perpendicular is del x. Del t. So del x by del t is nothing but slope of the graph. And the slope of the graph, as we know in the previous classes, signifies what? The velocity. That is the average velocity. The change in displacement divided by change in time. That is x2 minus x1 divided by t2 minus t1. All of you clear? It's a very important point. So now in this type of motion, we can easily find out the average velocity. Clear? And remember one, the slope of displacement versus time graph in this case gives me the velocity. So what about the A figure? Here the slope slope becomes 0 because there is no slope. Clear? But come to here. So here it will the velocity, the position becomes or the object moving in positive x direction. The object is moving in positive x direction. But look at here. It is having negative slope. The slope, if you find out, the slope becomes negative. So what does the slope negative mean? The slope negative means that the velocity, we will get the as velocity is a vector quantity, so its magnitude is always positive, but the direction is just opposite one. That is, in this case, the direction of the object is positive x direction, and in this case, the direction of the object becomes negative x direction. That's why the slope is negative. This is the main significance. Understood, all of you? And these are the two uniform one. Okay, but come to the D, the graph number D. The graph number D, look at it. The position is varying not in equiproportion with respect to time. The D signifies, the figure D signifies that the displacement will not vary in equiproportion with respect to time. That's why this is not a uniform motion. This is a non-uniform motion or non-uniform velocity. This object is having non-uniform velocity. So these are the two uniform velocities. This is the object is at rest, and the last but not the least, the last D is your non-uniform velocity. Clear? Okay, so this is a very important part, or this is the graphical understanding between the displacement versus time graph. So one most important point, one by one I will repeat. The slope of the slope of displacement versus time graph gives me velocity. If the slope is positive, then the object is moving in positive direction. If the slope becomes negative, as you can see in the your figure C, if the slope becomes negative, the object is moving in negative direction. And coming to D, this type of where that is not a straight line, x versus t, displacement versus time graph, that is a non-uniform velocity case. All clear? Now this is the displacement time graph. Now come to the second part, that is the velocity time graph. Okay, so this is the come to this part. So in velocity time graph, look at the graph, all of you. So this is the velocity is in the y-axis. The the time is in the x-axis. The velocity is noted in y-axis, and this is in the x-axis in time. Clear? Now look at the first one. Look at the first one. So now as the time progresses, the velocity becomes constant. The velocity becomes constant. What does it mean? It means the object is moving at a fixed or uniform velocity or a constant velocity. And what is the velocity I will take here? V0. Very simple. So as the time progresses, the velocity will not change. The velocity remains constant. Okay. So the object is moving with a constant velocity. This is the figure number A. Now come to figure number B. All of you look at the figure number B. Now figure number B, again it is in y-axis I have taken the velocity, in the x-axis I have taken the time. Now here also look at the figure. This is a straight line. This is a straight line. That means the velocity and time increases. The velocity increases with time in equiproportion. And what does it mean? Again I will repeat. It means, suppose I want to find out the slope here. In the displacement time graph I have done the slope. Similarly, suppose I want to find the slope here. Then what I could do? I could just extend it, and this is my angle theta. Look at it very carefully. This is my angle theta. I will extend it, and if I will extend it, then this is my P and this is my D. So what is P? This is your del B and this is your del T. So as the slope, slope is nothing but your tan theta. So tan theta slope is equal to del B by del T. So del B is equal to B2 minus B1 divided by T2 minus T1. Understood, all of you? This is my slope. So that means the slope of a velocity time graph gives me what? Gives me acceleration, as from the previous discussion. That is, the rate of change of velocity gives me the acceleration. So the slope of velocity time graph gives me a very interesting physical quantity which I have discussed in the previous one, that is your acceleration. Okay, so similarly, as the object is moving here, that means the acceleration, so the object is moving with a uniform acceleration. And which type of? Increasing acceleration. Okay, but suppose I will make the figure in this manner. All of you look at it. Suppose this figure I have to make a little bit change. This type of thing. Look at it. So this is your V, this is your minus V, this is your T. So look at here, all of you. Here the object is moving in negative direction. So this is your origin. I have slightly changed it. So this is similarly. Okay, so this is my slope. But interesting thing is that the slope is here is the negative slope. Understood? So negative slope means, so this is my slope. So this is your minus V1. Okay, so this is your minus V2. This is your T1. This is your T2. So similarly, in this case, you will get a positive slope. In this case, you will get a negative slope. In both the cases, the acceleration becomes uniform. Listen very carefully. In this case and in this case, in both the cases, acceleration becomes uniform. But in this case, this is increasing acceleration, and in this case, this is decreasing acceleration. That means retardation or deceleration. The decreasing acceleration is otherwise called deceleration or retardation. Okay, so this is your uniform acceleration, increasing acceleration. This is also your uniform acceleration, but in negative direction. So that's why it is uniform retardation. All of you clear? Okay. Now come to this C. So this is the origin. So let me look at here. This is the V, this is the T, and the graph is as the graph seen. So the graph is not for a uniform acceleration. It is a non-uniform acceleration because the velocity and time will not, the slope is not constant. It will vary continuously. Clear, all of you? Okay. So in this case, remember, in this case the slope is not constant, the slope will vary. So that's why it is a non-uniform acceleration. But B and C, these are uniform acceleration. Okay, and remember in this case, in these two cases, the instantaneous acceleration becomes equal to the average acceleration at a time instant. Again, I'll repeat, in these two cases, the instantaneous acceleration is equal to the average acceleration at a particular time instant. Both are same. Okay, and in this case, the slope is zero. Very simple. Slope is zero means acceleration becomes zero. So there is no acceleration. The velocity remains constant. Understood, all of you? Okay. So these are the sum of the discussions. A very important concept, important discussion about the displacement time graph and velocity time graph. All of you understood? Okay. So with this knowledge, let us now move into a very interesting part, very interesting derivation, that is kinetic equation. That is your kinetic equation. Okay, so you have to find out the equation of motion. The equation of motion, otherwise called a kinetic equation for which type of motion? Kinetic equation for which type of motion? Kinetic equation for uniform accelerated motion. Okay, so we have to find out the kinetic equation for uniform accelerated motion. We have to find out. Clear? And from using which type of graph is very important. Which graph? Which graph? The graph I will take as velocity versus time. Okay, so look at it, how we have done it. So suppose this is my graph. In x-axis I have taken as t, in y-axis I have taken as the velocity v, okay, velocity v. Now suppose, so this is your v. So now suppose an object is starting from not origin, starting from here at a velocity u, okay, and ending at a velocity v. Clear? Okay. Okay. So now at time t, again I will repeat, at time t the velocity of the object become v. At time t is equal to 0. So here I have to write here, at time period is equal to 0, velocity of the object v, velocity of the object is u, okay. At time t is equal to t, velocity of the object become v. Clear? Okay. So this is my assumption. So at time t is equal to 0, velocity of the object become u. I will assume that at t is equal to t, or time is equal to t. Okay. At t is equal to t, here in this case at t is equal to t means time is equal to c. If you are confusing, just write it here time, it is better. Time is equal to t, and here also you can write time is equal to 0. So I have taken this velocity of that become u and velocity of the object become v. So now just split the graph, okay. And one more very important thing I have to mention here, the area under the velocity, listen very carefully, the area under the velocity versus time graph, area under the velocity versus time graph gives me what? That gives me a very interesting physical quantity, that is your displacement. Velocity versus time graph, the area under the velocity versus time graph gives me what? That gives me displacement. Okay, so now then let us name it. So this is, suppose A, B, C points, D and O. Clear? So let us name it. Okay, so now these are the naming. So one by one, my aim is to find out the kinetic equation. Okay, the kinetic equation for uniform accelerated motion. One by one I have to find out. So first of all, what I have to find out? First of all, I have to find out the first equation of motion. Okay, I have to find out the first equation of motion. So for the first equation, what I have to do? What I have to do? Okay, so now at time 0, at time t is equal to 0, at time t is equal to 0, your velocity becomes u. At time t, the velocity becomes v. Understood all of you? Okay. So now that means I can easily find out that in this figure, suppose I want to find out the slope. First of all, I want to find out the slope AB. So now in the triangle ABC, in the triangle ABC, okay, so now what I can write? Slope. What I can write? Slope is equal to, so slope AB, just name it slope AB. Okay, so slope AB is equal to what? Now this BC divided by this. Clear? So what is BC? Now BD minus CD. So let us find out. So BC divided by AC. So BC is equal to BD minus CD divided by AC. So what is BD? BD is nothing but your V. Look at here, BD is nothing but your V minus. What is CD? CD is nothing but your U divided by what is AC? AC simply is your time. All of you clear? Okay. And this slope of a VT graph, as I told just now, the slope of a Vt graph gives me what? Now gives me acceleration. So let us name it as A. So that means that implies what I can write. Now V minus U is equal to AT. Clear? So give it equation number 1. V minus U is equal to AT. Very simple. So first equation derived. This is the first kinetic equation of motion. Which type of motion? The uniform accelerated motion. Understood? That is V minus U is equal to AT. Clear? Okay. Very simple. Or simply, if I resort it, then V is equal to U plus AT. Same thing. Clear? So this is equation number 2. Now, first equation derived. Come to the second equation. For second equation, what I have to find out? Now, from the second equation, I have to take the area. For second equation, let us find out. Let us find out the area. Area of what? The area of A, B, C, D, O. Area of A, B, C, D, O. So area of A, B, C, D, O. I have to find out. A, B, C, D, O. The area of A, B, C, D, O. I have to find out. Okay. So let us find out the area of A, B, C, D, O. So the area of A, B, C, D, O is equal to what I can write? Now area of ABC, area of triangle ABC plus area of rectangle, yes or no? Area of rectangle ACDO, ACDO, area of rectangle ACDO. So that implies, first of all find out okay, area of ACDO, ACDO. So what is the area? Now this is U, this is T. So area is UT. Very simple. This is area of ACDO, area of ACDO. Okay. So let us do. So this area of ABC, let us find out. So area of ABC. So what is the area of a triangle? Now half into base. So base is T. Okay. Half base into height. So height is nothing but how much? Now V minus E. This is your V minus E. Clear? Okay. Plus, and this is area of ACDO, that is UT. Clear all of you? Understood all of you? Okay. So now that, so this is, so that, and this is the area. ABCDO is equal to this much, and this is your VT graph. So area of ABCDO gives me what? The area under a VT graph. I told you area under a VT graph. So this is the graph. The area ABCDO. This area gives me what? This area gives me the displacement. Very simple. So that implies this area of ABCDO is the displacement. Area of ABCDO is the displacement, is equal to half into T V minus U. So what is the value of V minus U? Look at here. So V minus U is equal to AT. So let us put it here. AT. Okay. Plus UT. So displacement, suppose the displacement I will take it as S. Let the displacement be S. So S is equal to UT plus half AT square. So this is my equation number 3. So this is your first kinetic equation of motion. This is your second kinetic equation of motion. Understood all of you? Okay. All of you clear? Okay. So now, next what I have to find out? The last one. The next one I have to find out. Okay. For the next one, what I have to do? Let us think. For the next one, what I have to do? So that the next equation I can derive. The next equation I can easily derive. So what I have to do? Let us think. Okay. So this is my equation. S is equal to UT plus half at square. Clear? Okay. So now at value is v minus u. Look at it. At value is v minus u. Suppose in equation number 3 here I have to write okay, in equation 3 what I have to do, I have to put the value of this. Okay, so simply I have to rewrite it. So s is equal to half t whole into v minus u, okay, plus, okay, so let us write the last one better. So s is equal to ut plus half a t square. Clear? So that implies s is equal to, okay, so this is ut plus half in place of at, so at I will take it common and this is your t, so in place of at I can put v minus u. Very simple. Okay, so now that is equal to ut plus half v minus u t. Understood? In place of at, look at it, in place of at I have to put v minus u. This one equation number 1, v minus u. All of you clear? All of you clear? Now what I have to do? What I have to do? So just split it. So this is your ut plus half vt minus half ut. Okay, ut plus half vt minus half ut. So ut minus half ut. Look at it very carefully. Ut and this is minus half ut. So how much it is? How much it is? So this is your half vt plus half ut. Ut minus half ut. How much? Ut minus half ut. How much? Half ut. So half vt plus half ut. So that is equal to. That means I can take t the common. So v plus u. V plus u divided by 2 into t. This much. Clear? All of you understood? Okay. So now that implies. So s is equal to. So v plus u divided by 2 into then t. So in place of t, look at here again I will repeat. Go to the equation number 1. Again I will go to the equation number 1. So v minus u is equal to 80. So t is equal to v minus u divided by a. Yes or no? V minus u is equal to 80. So t, this is your t. So in place of t I have to put this value. So t is equal to v minus u divided by a. So let us put it v minus u divided by a. Clear? Okay. So that implies s is so v plus u into v minus u. How much? Now v square minus u square. Okay. V square minus u square divided by 2. Okay. So that implies v square minus u square is equal to 2s. Understood? So this is your 3 and this is your equation number 4. So all the 3 kinetic equation derived. This is your first kinetic equation. This is your second kinetic equation. And this is your third kinetic equation. Again I will repeat. First kinetic equation v minus u is equal to 80. Second s is equal to ut plus half at square. And comes the third one, v square minus u square is equal to 2as. So these are the 3 kinetic equations. Understood all of you? So in this way you can derive the kinetic equation of motion, that uniform accelerated motion. These are the 3 equations. Graphical, these are very important questions from the exam point of view. So very important. So go through the derivation very clearly. If you have any doubt, then you can ask me. Go to bit by bit thoroughly. Okay? Thank you so much. Have a good day.